Good input, thank you.
Thank you.
Hello everyone, I'm Clemens Carpadetti. I'm one of the co-founders and CTO of Solver Blockchain Solutions. We have been developed by Science Park Graz. We are a blockchain operator, a staking company, infrastructure, white label provider, and Appchain maintainers.
Hello? Okay. My name is Zoltán Fazekas. I worked for different L1s in the past 5 years in engineering, research roles, leadership roles, built an EVM-compatible L1 called Zilliqa, built an SVM, Polka VM-compatible one called Rialo. I'm handing over to you.
Hi everyone, my name is Marina. I'm leading the European Institute, which is basically an institute working in Europe on the adoption of Ethereum, but also on the regulatory side. So from this panel, I think for us it's also important what regulators ask when you talk to them about tokenization mostly, and what the requirements are there when it comes to different layer ones.
Hello. Hi everyone, I'm Igor. I'm investment director at Vienna Capital, where myself and my team develop investment and trading strategies focused on the entire blockchain stack, L1, L2s, Appchains, middleware. We also develop financial products as a combination or bridging between crypto and digital markets. One of them is the EU BMR regulated crypto index, which are listed on Bloomberg and Refinitiv, which are a basis for ETPs or ETFs, also for decentralized versions of ETFs called DTFs, also been launched by a company from the United States. And my view today is maybe from investor point of view, angle point of view, where the capital deployment makes sense in the context of infrastructure.
Okay, thanks a lot. Let's get started then. We have a mixed audience today, so I think it makes sense to have a little neutral definition between the differences of layer 1, layer 2, app chains. So it would be great if one of you could give a little short explanation about that we're all on the same page here.
Yeah, let me try. So on a very high level, a layer 1 blockchain is a sovereign blockchain. It does all the 4 jobs. There is a common model, 4 layers of 4 jobs a blockchain is supposed to do. It has its own consensus, so ordering transactions and ensuring finality. It publishes the transactions, the so-called data availability layer is the next one. Then it executes the transactions. Execution is the 3rd layer. And it actually has a baked-in settlement. It's not even a separate layer. So this is how a monolithic blockchain layer 1 works. And in very simple terms, I would say layer 2s are such that do not have all these components. They depend on a layer 1. In most of the cases, layer 2s inherit consensus settlement and can also inherit data availability from a layer 1 or use another technology. And this is actually quite established. If you are inside one ecosystem like Ethereum, it gets really messy if you cross the borders to other ecosystems. Think of Polkadot, Cosmos, etc., or even products that call themselves layer zeros. So they basically cause a lot of confusion, in my opinion.
Okay, perfect. So there's nothing to add?
I think it would also be important to make a differentiation between a general purpose blockchain and specified purpose blockchain. So an app chain, for example, it can be an L1 or an L2, but a general purpose blockchain can never be an app chain. A general purpose blockchain houses smart contracts and applications running on this blockchain. And the main thing to consider there is that the infrastructure layer isn't fully aligned with the application running it, whereas an application-specific blockchain, as the name describes already, the blockchain is made for the application. So you have everything, every principle, every primitive that's built for the application.
Maybe I would add another one, private and public. We have talked about it for years, but I think now Yeah, it works. When we are seeing more and more private blockchains coming up as blockchains used for tokenization mostly and adoption of institutions, I think this is pretty important, especially from our experience when we talk to regulators, really understanding what, for example, an open blockchain, censorship resistant, etc., what that means when it is baked into the technology versus something that is agreed within the governance of a blockchain that could be private.
Perfect. With this in mind, we can start with the real debate now. And from an engineering standpoint, I would like to know, is a single chain that processes everything, is that physically or sustainably possible, or are we running into hard limits at some point from a technical perspective? What's your guess there?
It depends on how far we want to get as the industry altogether. So currently we see actually an abundance of block space across all the blockchains, of course. I'm not talking about only one. There are high performance chains, think of, I don't know, MegaEase, Monad. They could process hundreds of thousands of transactions, and they do like 30 per second. On the other hand, there are use cases which are still not on a chain, institutional use cases where I know of one, I'm just not allowed to disclose who it is and what it is, where a single use case, a single major function within a single player or organization, global one worldwide, requires millions of transactions per second. So there's a huge gap between demand and block space available. Currently we have more block space than demand, but I hope with new applications coming on-chain, we will not only utilize the existing demand, but also need additional scaling.
Yeah, I think that's very right. You made the point about abundance of block space. I think on a high level, the whole industry feels kind of like it is post its .com bubble moment. So we have engineered a lot of solutions and a lot of protocols and blockchains and block space that's currently barely used. And that introduces a lot of fragmentation. And it's super critical to kind of like this next phase of the industry will focus on end user products. And this is very much what we're seeing today. And I hope that you're right, that we will see this application or these applications that in the future will bring millions of transactions per second or something. So we actually use that abundance of block space that we have currently.
Focusing on layer 1 blockchains like Solana or Sui or Cardano, I would like to know, can a single layer 1 become the settlement layer for the entire global financial system? Is this possible or is it not?
So, I find this question very, very interesting. In a way you can answer yes, no, maybe. The point is that what we refer to as the global financial system is in reality a total fragmented ecosystem of different transactional settlement bookkeeping layers that are very, very complex and very, very, very much fragmented across the globe. So you refer to it as the global financial system as if it were a single system, but that's not the case. So even if we, I don't think that there is any technical capability to develop a technical solution that would be useful or that could be used for a global system as a unit, as a whole. And even if that technical solution were to be possible, I don't think that it should be used, because that technical solution would have then this burden of a systemic risk for the entire global financial transactions in general, which is a very, very big thing. So in a way, what we have today is already an existing, let's say, ecosystem of settlement layers, different L1s. So we have stable coins, we have some CBDC pilot projects with settlement layers. L1s, I combine public and private chains or consortium chains. So they can, in this context, as an ecosystem of different settlement L1s, very much deliver this purpose or use or this function for the global financial system. But a single solution, I don't think it's viable and should be done because of the risks associated with it.
Maybe I would distinguish two different use cases. Like one is the one that is basically a private use case. Anyone decides today which blockchain they will use according to different standards. Maybe where I would point at this time, if the audience is interested, I think Open Zeppelin recently published a research on different blockchains from different categories. So that one, for example, is really interesting to look into if you're trying to decide which blockchain to use. But that's one. And then we see that regulators more and more, or different banks will adopt products or build products, and they will choose in the process which blockchain to use. So for example, in the European Union, currently we're looking into the Appia Impontes project, which is putting central bank money on blockchain. And there, I think it will be really important to see which type of blockchain they will choose to use. And it will be something that all of us will use because it will be somehow connected to the whole EU. And those are kind of like also looking into the criteria they're basically looking into for deciding.
Let's talk about the classic debate a little bit more, like the monolithic chain, like Solana, where everything is on it or happens on this chain, and the modular version, like Ethereum, where you have different layer 1, layer 2s. What is the strongest case for monolithic, and what is the strongest case for modular, so that we have both arguments? So, yeah, feel free to decide. I'll start.
I think, in my opinion, it's mostly about fragmentation, cross-chain composability, and user experience. So within a monolithic chain, the user experience is usually very high. You have atomic execution, which means that if you're doing a very complex transaction cycle, for example, you take out a flash loan, you participate in some arbitrage swaps, and then you transfer out the tokens to some destination wallet. If any of these intermediary steps fail, your whole transaction fails. And this is a very good user experience. This is what we're seeing today on Ethereum or on Solana, for example. So this is the general benefit of monolithic architecture. Whereas modular architecture introduces different venues, different liquidity venues mostly, and you also don't have any good atomic composability, which means the user experience in general, if there are multiple protocols involved, really lacks in comparison to a general purpose L1.
I do agree, but one of the major relevant points for both modular or monolithic chains is the risk surface, or also as an attack surface. So in a case of modular, you have everything is ripped apart. The core functions that Zoltan mentioned are all now individual modules that have technical dependencies, but also this introduces certain risks that come with it. And if, for example, DA is not available, the rollup freezes, so the transactions or settlement stalls. But on the other side, with monolithic blockchains, in a way, you have all these risks concentrated, packaged in a single protocol. So if the code base of monolithic protocol fails, then the blockchain halts. So it comes at the end of the day to the use case, which is maybe if you need like a general purpose computational solution to cover as much different use cases as possible, you go to something modular, maybe with a proof of stake probably angle. But at the end of the day, the limitation to also the scalability component has to do with the underlying consensus that you choose, consensus engine. So it's really like act of balance depending on the use case.
Solana has had several outages. Is this maybe the price for a high-performance monolithic chain, these outages, or is it something different?
Sorry, I didn't understand the word. As multiple?
Outages, like it failed like many times.
Outages. I don't think so. It's probably sloppy engineering or operation. But I would like to come back to your point. How bad actually it's not just the user experience, but the developer experience became. So in a monolithic blockchain, whether it was all the Ethereum L1 or Solana or the others, this fundamental primitive, like you write a smart contract, you write a program, it can build on other existing programs, it calls just a function of another program, and it calls a third program, and you can swap or do whatever you want to on the fly. So these programs, these contracts were composable. This was totally broken. At the beginning, it might not matter because you only see an isolated app chain or app running on a layer 2, which is fine on its own without interacting with others. But I guess by now we realized how badly this was broken, and if users even just want to interact with these different L2s or app chains, it takes minutes to bridge over tokens, because without tokens you cannot do anything. And then still you are just using a single application. It cannot really interact with each other. And what we have today, and that is not the end game, is just intermediary solutions, in my opinion, are aggregation layers. So different ecosystems, layer 2 ecosystems like Polygon's egg layer and zk-Sync's elastic chains and super chains by Optimism create some half-baked solutions, I would say, to get back this composability in some way. It's asynchronous. That's still far from the original experience, and by default, it's not even atomic. So it mimics basically what third-party bridges do when it comes to transferring tokens between, or messages in general, between chains. But in my opinion, the end game is still in the future. It's approaches like you may have heard of, that was recently announced, Ethereum economic zone, where researchers and companies come together like Zisk and Gnosis and the Ethereum Foundation and others to really provide the same synchronous atomic experience, composability experience as we had like years ago. So you can deploy a smart contract on one chain. It calls a smart contract that lives on another chain within the same transaction, executes immediately, and the whole thing returns a value and continues computing with that return value. The whole thing within one slot, within one transaction, within like today 12 seconds, in the future 4 seconds, and not after minutes of bridging and waiting for the result.
Thank you. Now I would change or switch to app chains. We talked a lot about layer 1, so now the app chains, I mean, Hyperliquid, I think it's the poster child right now. It's a derivatives exchange, very, very successful, with their own application, with their own chain, so not a shared chain. So that's, I think, the case there. And I would like to know, why is this model, this chain model, so successful for Hyperliquid? Is it like the advantage of owning the entire stack, or what is it?
To whom do you address the question? Sorry, I don't want to.
No, I mean.
Oh, okay. I think that Hyperliquid is a perfect pure-blooded app chain solution. I mean, its only purpose is, or the entire existence, the entire design is catered to one purpose: to enable centralized order book, to enable trading, and it doesn't care about VM optimization or smart contracts. It does not care about being the next L1 or anything like that. What it cares is what its users care about, and it's trading effective, cost-efficient execution, low latency, low slippage, deep order book or order book depth. Those are the things that Hyperliquid did very, very well, and it combined it, I would say, with a very good airdrop campaign, which ended up giving this positive feedback loop, attracting more and more capital, more and more mind share, more and more liquidity, and it's just kind of grew. And this is what they did very, very well. And I mean, they have one sequencer. It's fully centralized. They have a handful of nodes, and half of those nodes run in Jeff's garage, maybe. So, but it works. It works. And of course, it introduces a lot of different risks associated with it, but they did this component very well. We exist for trading, and that's it.
I would like to add and emphasize that it's not a matter of tech because they are an L1 and they own the whole stack and run the whole stack themselves. It's about having an application people want to use. Another example, not ranked that high on CoinMarketCap, etc., is Lighter, also new protocol, doing roughly the same. It's focused on trading, super capital efficient, etc. They are a layer 2 of Ethereum. They produce alone 10 times more transactions per second as the second and the third and all the rest of the layer 2s because people need it, people want it, people use it.
Yeah. I mean, the product market fit with Hyperliquid is like really, really spot on. But long before Hyperliquid, there was, and there still is, Dydex, for example. Mm-hmm. I mean, totally different ball game, totally different tech, but it never took off in a way Hyperliquid did.
I mean, DYDX very much felt the pain of Hyperliquid executing perfectly on what they were providing previously. But I think DYDX is one of the perfect and shiny examples why app chains are good for very mature applications. Because DYDX was running on Ethereum within a smart contract for a long time. And researchers have found out that they have been losing, I think it was over $1 billion in MEV to the Ethereum validators, to the base layer. For example, we're a validator, a top-ranked validator on the DYDX on the application-specific chain today. And because it's built on a Cosmos SDK, it is delegated proof of stake, and all the validators are publicly known. And users are now incentivized to delegate away from validators that behave maliciously by extracting MEV in any form. There's even this public kind of MEV shaming dashboard where you can just log on and just see how much value got extracted by which validator. And it's easy for users to choose to not delegate to this validator. And this is only possible because the DYDX is now its own application-specific chain. And the infrastructure layer is perfectly aligned. The validators are perfectly aligned with the success of the application and the token.
Just quickly, there was some time, like a year and a half ago or something, where a lot of projects announced their own app chain. Like, for example, different projects announced their own app chains, for example, different wallets. We have not seen that yet. And so I would just go back to the use case that, something that someone really wants to use. And there's a big community around that. And you linked the token launch, etc. It's a whole story about building a big project with the really capability of like getting the user interested.
From an infrastructure perspective, I would like to know, is the interoperability layer catching up fast enough for like, you have app chains, you have layer 2s, you have layer 1s, that they all can connect and talk to each other? Is it possible, or are we struggling with that interoperability?
Yes, catching up and working on it fast enough is relative. So what has been built already, not only for L2 ecosystems, but for these diverse chains, layer 1s out there all together, are two different layers of abstraction. One is what people may know as chain abstraction or omni-chain accounts. There are many names for it to create, for a user, for an end user to create the illusion you have a unified balance, a unified account, and you sign high-level intents. I want, 100 USDC wherever on a DEX, and you do not really care about the chains. You do not even care about how much of these tokens you hold on the different chains. There are some underlying mechanisms, solvers and some MPC and threshold signature mechanisms that do the job for you. You basically express a high-level intent and do not care about chains at all. This is on the user level. On the, again, developer smart contract level or layer, we have cross-chain messaging protocols, which I mentioned before. They try to mimic communication between smart contracts across chains. They are far from the synchronous experience we had before. There are many protocols out there like, I don't know, CCIP by Chainlink, Layer 0, and a lot others. They are all asynchronous. They all have to wait for some transactions or events on a source chain to be finalized. And you know, this finality is a property, is an individual property of every blockchain. It can take on Ethereum L1. Currently, it takes up to 12 minutes to get finalized. But these are all important for safety, so they cannot really be faster. What I'm curious about or excited about is our new developments. Which work on or towards this synchronous composability, where basically we have the same experience as we used to have in a monolithic L1, but these will take like probably years to emerge. They are on the roadmap of Ethereum, and I believe they will come, but they are in the research state currently.
Yeah, I mean, I fully agree. I was just thinking to add one minor point. We have bridges that connects all the different chain variations or flavors out there, and cross-chain messaging works, as we've heard, but what's lagging behind is, I think, the matter of liquidity and capital migration between all those, let's say, isolated or small island nations, because every chain is an isolated system in of itself, has its own, let's say, currency, society, economy, and how do you connect all of those? And then at the end of the day, the available liquidity and capital movement is reliant upon bridges, essentially, of different kinds of bridges, which has different layers of risks to it. So I think that in this context of the question, what's catching up is the ZK technology that I think is cornerstone development for this purpose, to have at the end of the day this absolutely trustless, permissionless movement of capital between different chains, and I think this is the next phase that will, let's say, complete the whole picture.
From an investor's perspective, it's really important who captures the value in and layer 2 words. That's, I think, a question many of you ask always. Okay, what's happening with Ethereum if all the money goes to Base, Optimism, Arbitrum, or what else for layer 2? So, what's your take on that investor's question? Who wants to answer?
Maybe I'll just kick it off. I think that layer 2's, Ethereum layer 2 specifically, are in a way competitors to Ethereum economic model. They have different incentives. Amongst others, they have, due to centralized sequencers, they also capture the MEV, which does not really flow back to the security, to pay for the security of L1. There is also this angle that every major L2 from the Ethereum ecosystem also has its own token, so which is not used specifically or only for governance purposes. So you have this, let's say, economic power struggle when, if for settlement, for finality, you pay Ether for gas for the L1, and for everything else you need the L2 token, then all the capture of economic value stays with that L2. But since we all know that we have like over 30, 35 different L2 flavors, they all compete between each others based on fees or speed. And this question, I think it's interesting because this third player enters the chat, which is applications. And if applications have this upper hand because they can deploy on multiple L2s simultaneously, they're not bound to a L2 to stay there. And in a way, they have this advantage that they can just move their user base somewhere else, which gives them, let's say, this advantage over all L2s, which are just fighting with each other based on fees. So if you have the control as an application over your user base, you control all the fees that come from your user base, including the revenue generation. And at the end of the day, a very small, a very, very tiny fraction of all of it flows back to Ether L1 for the security, for example.
In terms of numbers, today, at least over 90% of the value accrued on L2s stays on the L2s, goes to the sequencer. There are some new architectures or new developments like based rollups where the sequencing is happening on the layer one. The layer one block builders, proposers take on the role of the sequencers. In that case, of course, the value would flow back to layer one, but currently it's the layer twos taking the profit and
Please.
So I would just go back to the use cases. We're talking about a lot of use cases here about apps and dApps, and thinking about the future of the use cases. For example, tokenization. A lot of institutionals are using a layer one as well, and then thinking about this kind of the dichotomy between layer two, layer one, mostly looking into the security rather than the economic part or basically the time part, and then also looking forward into the future how the economic zone will work, etc. But I think that the use cases might be different for different occasions and different like layer ones or layer twos, and then somehow it will reflect in economics as well to see how many, let's say, transactions or usage we will have when it comes to tokenization versus the usage of the dApps today.
Okay. Unfortunately, we reached the end of time. Thank you so much. Thank you, Zoltan. Thank you, Marina. Thank you, Igor. Thank you, Marina. Thank you, Zoltan. Thank you, Clemens, for your valuable insights. It was a pleasure.
Thank you all.
thank you.
A round of applause, ladies and gentlemen. Also,